Okay, so this comes from the 2019 Reading Prelim. And so the question starts off and says, okay, you have a point A, okay, you've got two functions, okay, you've got the absolute value function, absolute value of f of x, okay, is equal to root x minus 1, okay, so f of x is equal to the absolute value of root x minus 1, which means that that turning point over there is 1, 0. Okay. And then you've got a cubic function, because if you times the side, it's obviously a cubic. And g of x is equal to x minus 2, x minus 3. So they've given you, there's an x-intercept at 0, but they haven't given you the whole cubic function. So it must continue, and there must be another x-intercept at 2, then it must turn, and there's another x-intercept at 3, right? So eventually, okay, this straight line, this will get steeper and steeper. So this straight line will eventually cross that cubic function over there. So the first question is, okay, give a rough estimate of, without calculation, state the number of solutions to the equation. Okay, well basically they've let the two graphs be equal to each other. They've let f of x be equal to g of x, so you're finding the points of so the question is asking about points of intersection. Okay, so how many points of intersection would there be? Will there be 1, 2, and later on, sorry, it's not to scale, you'd have your third point of intersection up here, because as I say, this graph will become steeper and steeper and steeper. Okay, so the answer to question A, okay, the number of solutions, there are going to be 3 solutions to this equation, which finds your points of intersections of the two graphs. Right. Then it says, give a rough estimate of the x-coordinates of A. Okay, well, the salient here, this is 0, this is 1, so A is in line with that. So I would say rough x, you can't really be wrong if it's anything between 0.2 and 0.8, I guess. So the x-coordinate of A, I would guess, let's make it 0.5. Okay, now it says, use Newton's method to find the x-coordinate of A, correct to 6 decimal digits. So guys, when you're using Newton's method, what Newton's method does is it finds x-intercepts of a curve. In order to find A, you're not finding the x-intercept of any graph. Okay, so, I mean, as it stands. So what you have to do is you have to get a function for your points of intersection. Okay? And then you have to find the x-intercept of that new function. So, first of all, to find your point of intersection, I've got to get rid of the absolute value. So remember an absolute value branch, okay, you've got this absolute value graph over here. This kind of absolute value graph, this is the function y is equal to absolute value of x minus 1. Okay, what will be the equation of each branch will be, well remember the definition, you can just do the shortcut and use the logic that the absolute value of x is plus or minus x. Okay, so you could say the absolute value of x minus 1 is equal to plus x minus 1, or minus x minus 1, minus x minus 1, which gives you x minus 1, or minus x plus 1, and then pick which branch is obviously more obvious. So you could do it just by thinking about it. Okay, this branch has got a negative gradient, so this must be the line y is equal to negative x minus 1. If you wanted to use a definition, remember the definition of absolute values is the absolute value of A is equal to A if A is bigger than or equal to 0. Let's say absolute value of x is equal to x if x is bigger than or equal to 0, and it changes signs if what's inside is less than 0. So the absolute value of x minus 1, okay, is equal to x minus 1 if x minus 1 is bigger than or equal to 0, and it's equal to negative x minus 1 if x minus 1 is less than 0. You wouldn't have to show any of this. And I'm just giving you a little brief revision of absolute values. So that would be equal to, in other words, this absolute value graph is made up of two straight line graphs. The graph y is equal to x minus 1 if x is bigger than or equal to 1, and the graph y is equal to negative x plus 1 if x is less than 1. Okay, is if I had y is equal to, those would be y is equal to. So you're drawing the graph, y is equal to x minus 1, okay, when x is bigger than 1, so that would be that part over there, and you're drawing the graph, y is equal to minus x minus 1 if x is less than 1. Okay, wouldn't have to show any of that working, but you do have to recognize that when I'm solving this equation, because the question is, I'm ready to find the point of intersection, I'm solving that equation, now I can't work with the absolute value. So at A, we're on the negative part of the graph, so this is really the negative, that's the graph of y is equal to negative x plus 1. Okay, so you find the point of intersection of this blue line and this yellow line over here, okay, which is the graph x, x minus 2, x minus 3. Okay, so at A, we have the two graphs each equal to each other. So y is equal to negative x plus 1. So negative x plus 1 is equal to the cubic function x, x minus 2, x minus 3. Okay? So you're going to have to times it out. So you're going to get negative x plus 1 is equal to x, x squared, minus 3x minus 2x is minus 5x, plus 6. So therefore negative x plus 1 is equal to x cubed minus 5x squared plus 6x. Okay. Now you've got to find the x-intercept of this thing over here. So you're going to have to get everything to one side, and you're going to say 0 is equal to x cubed minus 5x squared plus 7x minus 1. Okay, x given on here. Okay, and now we're going to have to give this new function a name, because I'm going to now find the x-intercept of this new function. So I'm going to let, well, we've used f and g, so I'm going to let h of x be equal to x cubed minus 5x squared plus 7x minus 1. Okay? Right, so what I'm doing, I did it over here, I'm finding actually, that is this function there. That's a function that is x cubed minus 5x squared plus 7x minus 1. That's this function over here, x cubed minus 5x squared plus 7x minus 1. Okay, down here. Okay. And I'm finding that x-intercept over there. This is what this is Newton's method. So I've got this new equation, and I'm finding the x-intercept of that equation, okay, which is going to be the same thing as, okay, which is going to be, here's that function. So when I'm finding the x-intercept of that, what I'm doing is I'm finding the point of intersection of A over here. Okay, but I've got to get it to a single equation. So now the question becomes basically use Newton's method to solve this equation. So to find the root, the x-intercept of that equation. So my equation is h of x is equal to x cubed minus 5x squared. This is my equation for the points of intersection of the two graphs. And we're going to find the x-intercept of that over there. So you go to your formula sheet, and we have to use Newton's method to do that. And you go copy down the Newton's method formula, which says that x to the r plus 1 is equal to x to the r minus f of xr over f dash of xr. Okay, so we're going to be using this formula. The difference is, I guess, that now we're going to be doing it in terms of h. So I guess I'm going to rewrite it here as instead of f, the name of the function we're working with is h. So it's going to be h of xr, h dash of xr. So in order to use the formula, okay, so I'm going to say x, you always have to write this part out. So I'm going to get x to the r plus 1 is equal to xr minus. Okay, then I've got x cubed, you don't have to have that bracket, minus 5x squared plus 7x minus 1. Okay, that's h of xr. I actually like to write the xr in to be strictly mathematically correct. Okay, so that is h of xr. Okay, all this is saying to you is that your next guess is the previous guess minus, okay, your first estimate, you minus this whole thing over here over h dashed of xr, and h dash, the derivative of this is going to be 3xr squared. Okay, if you just write x is not xr, that's fine. Minus 10xr plus 7. So that's our Newton's formula for this particular graph over here, for this particular. So now we're going to apply the iteration process. So what you're going to do in your calculator, okay, is you're going to write down a legitimate first guess for my point of intersection. Now they ask you that over here. Give a rough estimate of A. Well, an educated guess for what A was halfway between 0 and 1. So I would say your first guess, good first guess would be x is equal to x0. The first guess we call x0. So x0 is equal to 0.5 is your first guess. Right. So now what are you going to do in your calculator? On your calculator, okay, so this is on your calculator. On your calculator, you're going to enter your first guess. So you're going to go 0.5 and press equal and then clear your screen. So 0.5 is where it is now stored into your calculator and will appear whenever you press your answer button. Okay, so on your calculator now, you're going to enter, okay, wherever you see XR, you're not going to press 0.5, you're going to press your answer button. Okay, so you're going to use this formula, wherever there's an XR, you're going to have answer. You're going to press answer. So on your screen, it's going to look like this. X, you're going to have, if I go down here, I'm going to have answer minus. Okay, then answer cubed minus 5 times answer squared plus 7 times answer minus 1. If you put 0.5, it won't iterate the process. Okay, because it's going to keep doing your next answer, your next answer, your next answer. Okay, and at the bottom you're going to have 3 times answer squared minus 10 times answer plus 7. Okay, so this is what your screen should look like. So after you've entered 0.5, press equals, clear your screen. You're now going to go enter this exactly on your calculator and then press equals. Okay, and if you've done it correctly, you should get x1 is equal to 0. That basically means that your first tangent would give you an x-intercept of 0. 0 is a legitimate answer. You press equals again. Now, sometimes I say to you, write down all your iterations. That means write down all your answers. And then you just press equals again. So you've got your first answer, press equals again, and you'll get your second answer. Because it's repeating this process. And I got x2 is equal to 1 over 7. Now, the question said they wanted the answer to 6 decimal digits. Okay? And if you write down x2, you get 0.1428571. Okay? If they want 6, I always do it correct to 7 and then round back. You should then get, if you press equals again on your calculator, your next answer that appears should be 0.142, x4 was equal to 0.160, sorry. Okay, so x2 was 0.142, okay, 8571, sorry, x2 was 0. No, x1 was 0, x2, okay, then x3, okay, you should get equal to 0.1604554. Okay? Press equals again, and hopefully we start seeing some recursion now. and I get x4, okay, is equal to 0.16071318. Now, at this point, you're looking for repetition. You got an answer correct. You know for sure that it's going to be correct up to 0.160. Okay? So that would be if I wanted my answer to 3 decimal places. But the question says they want the answer to 6 decimal digits. So if you press your calculator again, x5, we should get equal to, it was an 8, 0.16071328. Now, how many numbers are the same now between the two answers? Well, it's the same up to 0.160713. Okay? Which is 1, 2, 3, 4, 5, 6. To be safe, okay, I always go one more than they ask and I round back. In other words, if I press my calculator again, I go 0.160713. Something, I don't know what the next number is. But now, okay, we've got correct. Those all repeat, which is 7 decimal places. 1, 2, 3, 4, 5, 6, 7. Okay, so you've got 7 decimal digits. Okay, you only want up to 6. So I always go round back. If this number 2 had been a 7, that 3 would have become over here, would have become a 4 if you round back. So I always do one more and then I round back. So your solution is the x coordinate of A, okay, is going to be equal to 0.1607. Sorry, x is going to be equal to 0.160713, and that's correct to 6 decimal digits. What have you worked out? You've worked out the x-intercept of this point of intersection over here, okay, which is 0.1607. What Newton has actually, you did some calculations first, what Newton's have actually done is it's found, it didn't even know about the point of intersection, it has done, Newton part of the sum is over here, okay. It has found the x-intercept of this graph over here, which is this thing over there, and as you can see, okay, that looks kind of right. So that x-intercept of our combined function is at 0.16, whatever we just worked out over there. Okay. Okay, that's a bit of a tough question to start. Okay. Easier questions or examples in your textbook. Okay, I will carry on with the next video, the next one from your prelim. Okay, Dokels.